Hi there, this is Trace, and we're going to do some more data processing. The last video I said that we were doing some data analysis, but in reality we were doing some data processing on that video. We'll cover some data analysis in a future video, but for now, let's begin. Start off with a design, or let's go with the math at first. So this is where we left off. We went and constructed a line, a function, and with that function we came up with an integral, a total area of 0.0517, which should actually be 0. Let's go ahead and turn off this scatter plot here. So I went ahead and made some adjustments so to this function where it's so it's closer to 0. It's not exact, but it's closer to 0 now. So let's take a look at that one. So that would be this guy here. The scale is a bit different, but it's the same function here. But I went ahead and adjusted the area in such a way that it's closer to 0. So let's take a look at that. So let's do a integral of this function. Now we're looking at 0.00039, which is, it's pretty close to 0. All right, let's go ahead and shut this off here, or go ahead and delete that. And we can delete this point here, point here. Now we're going to begin by, for our initial data processing, we got to take this function and just shift it over just a little bit. So the beginning of the function's right on 0. It just looks better that way. So what we do is we shift this function. So this is function 20, and we just phase shift it just over just a little bit, just to so it starts right off at 0, right? Let's hide this one. All right, let's zoom out. Let's rescale it. So this would be this function here, and this will be the first interaction of our magnet here. Right, so let's take a look here at this guy here. So escape. So if we were to move this, so actually let's take a look at this here. So we got the stator here, which is the 5 magnets on the stator, and then the rotor, which would be this clear part with these colored magnets here. Let me hide this body here, so that gives you a better look here. So if we were to move this interaction here, let's select body. That one, that one, that one. Origin. So as that, let's take a look at this one magnet here. If that was to move across this one magnet here, that's what we're recording, or what we did record. And that's what's on the mathematical model right here. That would be this interaction right here. But now if you continue on and that would just be one part of the whole. This would rotate 360 degrees, so it would have a total of 5 interactions for just this one magnet. So go across this face, that face, this face, all the way around. So how can we mathematically represent that in the math model? So let me show you what I did. And so I took this function here. So this would be function 21. And go to the next function. So we got function 21. And then I add it to the same function, but now this function 21, I would just phase shift it over. And then I'd add it to the same function, but that portion would be phase shifted over, and so on. So let's take a look at that. So you see how that is? So that one magnet going on the rotor, rotating 360 degrees and having 5 interactions with 5 magnets on the stator, this is what it would look like. Okay. Let's take a look at this. Let's turn that one off. All right. But now I got this in a different function here. I'm going to turn this one off. Hide. So there we go. We got this one. So it's in blue, okay? And on this, escape. Let me hide this body. So if we take a look at this one, this would represent the blue function right here. So if we were to go all the way around 360 degrees, we have 5 interactions, okay? That would be this guy right here. Now, how do I represent? Oops. This red magnet here is it's going to have 5 interactions, but it's phase shifted to slightly different than the blue. Well, I take that and I slightly phase shift it as well. So there we go. That will be the red magnet on this here. So we got the blue and the red represented. Now let's take a look at the green. There we go. So this would represent one full revolution of the rotor in relationship to the stator. And this is what we got total here. Now I could go ahead and add, create another function to represent all 3 of these different functions, which is this guy right here. What color do we want? Oh, orange. So that would be all 3 functions. So that would represent everything. Now I could try to do an integral with this function. I'm just not quite able to grab a hold of it. There's something, I'm not sure what's going on with this program, this math emulator, but I can't do it on that function for some reason. But let's go to these other functions. So let's go back to, let's turn these off. And we could turn this one off too. Now, if we were to go back to our original function, what's the original? No, let's go back to this one right here. And we're to do an integral with this one function. Integral. And this one we got 0.0041. Let's grab this guy here. Control copy. Paste. All right. Now let's take this one and delete this. All right, so let's go back to our other function here. So we got the area of the integral at for that one function, just that one interaction at negative 0.000041. Now, if we were to go and get an integral of this guy here, now we got 5 interactions here. So what we got going on here for integral, just like that point, takes a little while to here. We got an integral of negative 0.000204, but that's 5 interactions. So we'll just take this times 5 equals 0.000205. So it's right in there. So that's what we're going. That's going to be the total area. But in reality, this should be 0. So you guys know. All right, let's back this up here. Delete. All right, so we got our 2 functions there. Now we have the 0.0025, which is essentially 0. We'll go over to this final function. These all added up. If we were to do an integral of all these, this total interaction for that rotor to rotate 360 degrees, this is going to be the interaction. And if we were to take an integral of this, it would be essentially 0. It just, the negative portion is canceled out by the positive portion of this. Everything above the line here is positive. Everything below the line here is negative. So it's really important to understand that, guys. All right. So I think we're going to leave off here today. In the future videos, well, the next video will cover a few more combinations that I came up with. You know, I came up with a whole load to see if I could get something to work. And I'll show you some of those combinations, and then from there we'll cover my final analysis. The final analysis is going to be its own video. Okay, guys? Peace.